So, how time and interest affect money? How N and I affect money? This is really important. We use something called single amount factor, F given P and P given F. Now, we change it from the mode of learning that we can get the equivalent of P to F or F to P to how to estimate P from F or F from P. How to change the cash flow from the principal I have on 0 to its equivalent on N. And if I have P, I can obtain F, which means if I have money right now and I put it in, or I deposited it in a bank at interest rate I, if I would like to know what should I have after n years, I just use F given P. I have certain amount of money now, so this is P. I need to understand or to know how much would I have after n years, which is F in the future, which means that it's F given P. And this factor, we learn it F given P if I put my money in a bank at interest rate I% and after n amount of years. So this bracket, we use tables to find out the number from this one. Okay, so let's see. So the result of investing P amount at I interest rate in n years such that F equals to P, F given P, I and N, which is Pi plus 1 over N, or to the power N. Similarly, if the investor have the future value or needs to gain an amount of money at in the nth year, okay, and he needs to know how much he should invest right now. So the investor can estimate the principal, which gives F after n years, value in future at the interest rate I in n years by the same way, which is P equal F multiplied by P given F, I and N. And so the formula is F multiplied by 1 plus N to the power negative N. Okay? This bracket P given F, I and N, or F given P, I and N, can be easily estimated from tables. We will learn how to do this in that short time. So, summary to the single payment, we call moving from P given, we call finding the equivalent of P, which is given, to F, which is required, or the equivalent of F when it's given to B, which is required, as a single payment analysis. And the single payment analysis can be gets notation of F given P, I and N, and this is I need future if I have present and interest rate I and N amount of year. We call it single payment compound amount if I need future from present. If I need present from future, I need single payment present worth, so I need to change the single payment from future to present, so this is present worth, single payment present worth. I use the factor F given P if I need future from present. I use factor present P given F if I need present from future. Let's say something like this. I consider this here present if I want to move it to the right side. So I use it F given P if I need to move this point to this point. If I consider this F, if I need to move this, let's change the color. I consider this f if I want to change this point from here to here, and I use p given f. Okay, so this is the formula. This is the formula we use to extract the value of f given b, I, and n from the table, and this is the real formula, the mathematical formula, and this how to use the Excel sheet. Actually, there are here two commas after n. So fv, I need the future value. If I know that the interest rate is I%, n is in years, and comma, and I write down the present value. So I just go to Excel. I say I need the future value. If I know that the interest rate is 10% and the N is 10 years and two commas and the present value is 1000. Once I click enter, I found the value of the future value. Okay, let's get an example. A cement factory case. It is Houston American Cement Factory will require an investment of $200 million to construct. So he needs now $200 million. Delays beyond the anticipated implementation year of 2012 will require additional money to construct. So if he delay it after 2012, it will need additional money to construct the factory. Assuming the cost of money is 10% per year, so this is interest rate. Compound interest, to understand the meaning of compound interest. Use both tabulated values and spreadsheet function to determine the following for the board of the directors of Brazilian company that plans to develop the plant. First, he needs the equivalent investment needed if the plant is built in 2015. So now he is in 2012 and he needs to estimate the investment if he needs to pay. He said actually 2015. So he will delay for 3 more years. The second one is the equivalent investment needed had the plant been constructed in 2008, if he would finish it in 2008, and now it costs him $200 million. So he needs to know if he need to finish it here or if he would finish it here. What do you expect? The number here is bigger or here? Let's see. The expected investment, now we said the same, we wrote the same. This is $2 million at zero right now, 2012. If he would pay it, so this is now, I said if we move from here to here, so this is P given F. If we move from here to here, this is F given P. N here is from 0, 1, 2, 3 from 2011. I just renumber the values. So 0, 1, 2, 3, and here -1, -2, -3, -2, -5. So -4, sorry, here, -4. So here I need P4 for P, and I need F3 for A. And just you can read the equation. So F3 will equal P given F3 will be F given P multiplied by F given B, I, and N, which is P multiplied by P given F 10% and 3, 200 multiplied by this number we extract from table. How to extract from table? I'll make a different video for that. Okay, it will be $266.2 million after 3 years from now. But if I constructed the factory in 2008, it means that I have the amount now and I need to go back, which means it's present with respect to now, and now is the future with respect to 2008. So I need P -4 So money now is F. The money right now is F because I moved from the right to the left. So this is F and this is present. So F, P given F, I and N. And F is $200 million. P given F 10% and 4 years. Negative 4 does not mean that I put negative 4 years on my real bracket, but it is 4 years. I just count numbers. So 200 multiplied by this number I extract from table, it is 136.6 million dollars, which means that if I finished it 4 years ago, I would pay less money because the interest rate real really affect and it really matters. Thank you.